Let's do a overview of the light reactions in more detail. I'm going to teach them to you in chronological order so you have a good idea of what is taking place first, and then we'll go from there. So here we go, let's begin. Light strikes the chlorophyll inside of photosystem 2, causing the chlorophyll to become energized. The energy is passed along to these chlorophyll atoms, and these particular chlorophyll A's will get oxidized, losing their electrons to a primary electron acceptor. When this occurs, the electrons need to be replaced in the chlorophyll A. Therefore, the electrons need to be taken from somewhere, and they are taken from water. Water is split, forming oxygen gas, and H pluses or hydrogen ions, or protons, the same thing. They are produced and they start building up inside of the thylakoid space. Now we have replaced the electrons, and we can continue on this path. The primary electron acceptor then passes on the electrons through a chain of reactions called the electron transport chain. This chain of reactions creates energy. The energy created from this chain supplies the energy to pump H pluses or hydrogen ions into the thylakoid space. Once again, we have a buildup of hydrogen ions inside of the thylakoid space. Now we're going to go to photosystem 1. Photosystem 1 works like photosystem 2. Chlorophyll absorbs light, the energy is passed along, chlorophyll A gets oxidized, the electron goes up to a primary electron acceptor at a higher energy level. These electrons need to be replaced, and they are replaced from the electrons that come from the electron transport chain. Now we're at the primary electron acceptor. This primary electron acceptor then donates the electrons to another electron transport chain. In this other electron transport chain, NADP, which is an organic electron carrier, combines with H pluses and electrons, forming NADPH. This is one of the first major products needed to take into the Calvin cycle. Now we need to talk about how ATP is produced. ATP is produced when this massive imbalance of hydrogen ions want to diffuse out of the thylakoid to the stroma. As these hydrogen ions are diffusing out through the ATP synthase protein, they are allowing the coupling of ATP production. So the movement of hydrogen ions out helps ADP attach to phosphate, forming your ATP. Your ATP then is also funneled into the Calvin cycle. So the two major products, NADPH and ATP, are both needed in the Calvin cycle, which will take place inside of the stroma.